Here's another question. The diagram shows a rectangle ABCD in which AB is 5, BC is 3. Point P lies on DC and AP is an arc of the circle with center B. Okay. This is important. Let's reread this. AP is an arc of a circle with center B. Where's AP here? So it's an arc. So it's part of a sector and the center is B. So this would be that sector they're talking about. Which means that this line would be 5 as well. Okay. And then it says point Q lies on DC and AQ is an arc of a circle with center D. Okay, let's also mark this in the figure. So yeah, we can tell that this is another sector. That means that this is 3, so this would be 3 as well. Okay, so we have two sectors mentioned in the question. We have to show that angle ABP, where is this angle right here? So we have to show that this comes out to be 0.6435 radians after rounding it off to 4 dp. Okay, that looks pretty straightforward. Now we can find this angle using SOHCAHTOA and then subtract it from pi by 2, which is 90 degree in radians. Okay, so let's start. This angle would be cos theta equals 3 upon 5, which gives us theta equals 0.927295. And then you do, this is the working of part 1, by the way. And then you do pi by 2 minus answer. That would give 0.64350. And when you round it off, you get 0.6435 as shown. Okay, so this angle came out to be 0.6435. Okay. Now the next part says calculate the areas of the sector BAP and DAQ. Oh, there's another part, by the way, that I haven't copied. Let me copy it now. This question also has a part 3, which is this, calculate the area of the shaded region. Okay, so back to part 2, where we just have to find area of the two sectors. That's the easiest question. You just have to apply half r square theta. So for sector BAP is this one, the bigger one. This is 5, this is 5, and the angle just came out to be 0.6435. So the area is going to be half r square 0.6435, half r square theta, which comes out to be 8.04. 3763, which rounds to 8.04 in 3 significant figure. And area for this sector is going to be half r square theta as well. So half times 3 square times theta is 90, which is pi by 2 in radians. And this comes out to be 7.06858 rounded to 7.07. Part 3 is find the area of the shaded region. Okay. Now, the shaded region is this entire sector, but from this, you have to subtract this part as well. So we know area of the sector, we just calculated it 7.06858. But how do we find the area of the blue part to subtract from it? Okay, so part 3 would be area of this, which we already have, minus area of the blue part. Now, if you look at the figure again, notice that you can find area of the blue part by taking area of this trapezium and then subtracting area of this sector from it. So trapezium area minus bigger sector area would give us area of this blue part. So what we'll be doing here is we'll be finding area of this trapezium. This side is 3, this side is 5. We need this side of the trapezium. And how do we calculate that? That's easy. This side is 3. This side is, sorry, that's 5, that's 3. So you may apply Pythagoras theorem here and get 4. So also please know that this is a very typical triangle that is usually given in the question. You have 5 as hypotenuse, and if you know one of the side, for example, this is 3, then this will definitely be 4. Or if that's 3, then that's going to be 4. It's a very commonly asked right angle triangle. So without any working, you may write 4 here and then you may write 1 here. So that's 1. Now from this, we subtract area of the sector, which we've already calculated, by the way. So this is 5, and this is 0.6435, but we already have that. So let's just enter the values. So area of this sector came out to be 7.06858 earlier, minus brackets, area of trapezium would be half times sum of parallel sides times height, minus area of the green sector, that came out to be 8.043763 earlier. Subtract these two and then subtract the result from 7.06, and you should get 6.11 after rounding.